Well, hello and welcome to Jim's radio shop, where we're going to be working on this OTL amplifier, and my assistant Draper is here with me, and of course he's checking out the bench arrangement and making sure everything's ready to go. Good thing I don't have my soldering iron switched on yet. So what we're going to be working on today is the OTL amplifier, and we're going to continue trying to achieve proper balance in the output. Thank you very much for helping me with my oil can. Mr. Draper, maybe going outside would be a better thing than goofing around in here, right? Don't you think? Yeah, why don't you go upstairs and bother my son? That'd be a good idea. No, he's going to stick around with us. Okay, so my first challenge is to give you a good camera angle. So I think I'm going to try this one. You may see my back a fair bit. Start off with this anyway. Okay. Now we're going to want to monitor the output here. And we'll do that. Use this meter here. Okay, we don't need to put an input into it. I've done that previously and discovered that the amplifier is actually working quite well. All we need to do is figure out what it is that's causing the imbalance. The imbalance voltage on the output is monitored by some circuitry in the amplifier. If it goes beyond 1.5 volts, the output gets cut off to protect the speakers. And that's what's happening. It is going beyond 1.5 volts. And when we do get it into the stable range, less than 1.5 volts, I cannot drive it down to 0 through adjustment. So the suggestion there They have a very curious cat here who's quite interested in electronics and sees a big future in assisting me with my work. Apparently decided that getting into my shelf would be a good idea. Okay. I'm not so sure he's too helpful. Carrying on here. These tubes, I guess these would normally be paired or something like that, but I'm not aware of any particular pairing. And the instructions I've received from the owner and from the designer is to go ahead and just swap these tubes around and try to find a particular arrangement that provides a balanced output, or identify which tube is misbehaving. And I think I already know which tube is misbehaving. I think it's this one. But I'm not sure. So our tests today are going to be done, intended to detect that that's a bad tube. I'm going to get some spare tubes. Hold on. Okay. I'm not finding my spare tubes. can't find them either, can you? Okay, I found the spare tubes. Got them here. Now, I have a set of 4 spare tubes. The fact is, the one that I'm suspicious of is one of the 4 spare tubes. So I'm not so sure it's a good idea to continue to try the spare tubes. I don't know whether they were older ones or what, but I'm very suspicious about this one. So, this is the tube that was in there. Here are 3 more. Let's take a look. But what I found on the spare tube was the pins were badly corroded. I'm wondering if they're all badly corroded. Oh, how terrible. Yes, they are. They're all corroded. Not this one. So this is the original tube. I'm trying to remember why I thought I should replace it. Watch back my videos and remember why. So I'm tempted to put that one right back in the circuit. Why don't we do that? Take out this one. Put this one back in the circuit. There were a number of component problems inside the amplifier, and those were probably the original problem, the very bad offset. Those problems have been fixed. Oh, I remember, this is the tube we saw a flashover in. Yeah. That's right. Yeah, so let's not try this one. So we want to see that again. Let's try another one. Now, if you've watched the video on the pins on these tubes, you'll know that one was badly corroded. This one's also corroded. So we're going to want to clean off that corrosion first. I need a little piece of sandpaper to do that. Yeah, I've been having trouble finding my sandpaper lately. Which I used to always keep right in here. There's some. There's some. Pretty fine grit stuff. Here we are. There we go. Now, I am just kind of guessing at this point that the tube I'm about to change is the cause of the problem. But it's a reasonably good guess. And it's worth jumping to that conclusion and trying it out. Oh, there's my assistant once again. He's returned. We have more than one cat. He's the only one who's awake right now, and he's a little frustrated because he's got nobody to play with. So I guess he's decided to come down and help me out. I don't need any help with things getting knocked onto the floor, though. That seems to be his specialty. He also likes little paper balls. Let's try one. No, that's my sandpaper. Here. You ready? Ready to leave the shop? And there he goes. He'll be back. That'll buy me about 3 minutes. Maybe only 2 minutes. Okay, so we'll put that. Take a look at that. Yeah, I think that's good enough. Put it in. Okay, let's switch on my meter here. What I do with my meter is I'll move the zero from the left end of the scale. I'll put it up in the center, and then we can watch the meter move back and forth if we're able to get this guy to work at all. Put him on a 5-volt scale, which means the movement will only be a little bit before it encounters before the protection operates. We have a dummy load on the amp. Like that. Power connection. Power's on. No, the power is not on. The plug is in. My cup of coffee is missing just a second. Okay, now I found the plastic golf ball, the wiffle ball. Next time my assistant comes by, I will use the wiffle ball. Okay, I think we're just about ready to turn this guy on. Let's review what'll happen. I'll turn the amplifier on. An internal timer begins to count down 45 seconds. At the end of 45 seconds, the amplifier protection relay will close and the outputs will become live and the meter will react. If the imbalance voltage is greater than 1.5 volts, the protection will operate right away. The meter will fall to 0, and we'll have to go through another setup process to get the bias voltages close to being balanced, and then try it again. And we're going to have to repeat this probably many, many times. Okay, Mr. Assistant, you can't be up here during this part of it, so I will use what I do with it. Where'd the wiffle ball go? Yes, magic bullet. Oh my gosh, here it is. Look. Ready for this? Okay. While my assistant is preoccupied, let's bring this up to center. There we are. Now I could start this up on current limiting, but I'm not going to, except for a very brief moment. When I put this on current limiting, it's a good chance it won't balance and the protection's not going to work right. It won't get anywhere. It's got to get full voltage. The other thing is that this amp gets really hot really fast. So you can keep your eye on this fan, cooling fan. The cooling fan closes in when the terminals are live. And a rather strange thing is if the terminal protection operates, the fan stops. But these keep going. Not the best arrangement. So. Okay, this main power switch is off. I'm applying power. Today our line voltage is about 118. These were designed for 110. I don't think it makes much difference. 118, 110. When I turn it on, this is going to drop to around 110. So remember, 45 seconds. We need to watch for 45 seconds. And then go, oh, you can't be up here, mister, during this process. No doubt he's lost the wiffle ball already. Come on. What do you do when you got a cat that's just too friendly? So I think I'm going to move you over here. Different view of things. Okay, you're going to stay there? Yes? You're staying there during this test? Okay, you stay there. Here we go. Okay, line voltage has dropped to 114. We've got to count 45 seconds, which is quite a long time. You should see 3 tubes lighting. They are lighting up. I'm not sure you can see that in the picture there. Now I've got to keep my eye glued on this meter. This may only last a moment. You should see a little flick in the lights too when the 45 seconds comes. There we go. And it just came on and went right off. Okay. Next stage is to try to operate the amp with just one pair of tubes. Put those out. Put them here. I've had a little bit more success with this. Let me get my documentation out here. I have had some success in operating this set with 2 tubes. Seems like as soon as I put 4 in, I have trouble. Okay, so what we should be looking for paperwork. Okay. Okay. I'm missing one sheet. These are always like that. There it is. I'm not missing it. Okay, Mr. Cat. Yes. Now we're going to fire this guy up. We're going to read the grid voltages to see how balanced they are. There we go. Okay, now, Mr. Cat, if you just stay right where you are, you're okay. What a crazy cat. I had no idea he liked electronics. Okay. I will still be able to monitor the difference voltage up here on a meter you can't see. This guy's set to the right DC scale. Are you ready? There we go. Gotta wait till 45 again. Don't knock my meter down, Mr. Cat. Okay, so the easiest thing to do here is to clip the negative lead of my voltmeter to the chassis. I don't have to worry about it. Look at that. Okay, coming around. There we go. Fan is on. So now you see the amp is actually working. It just won't work with the other two tubes. So grid voltage. You read minus 51. Minus 49. 49 versus 51. So these two should read the same. So I do have an adjustment here. Drop the 51 to that's around 50 in the other one. Oh, they're almost identical. 50.1. Okay, so these are completely balanced now. And the balance on the output is very good. It's right on 0. Okay, let's, I wish I could just drop the other tubes in, but I'm sure I can't do that. So, shut it off. Install the two tubes. Don't dump anything here, cat. I guess, I know, my assistant is saying the secret is in the documentation, but he won't let me look at it. He's decided to sit on it. In my voltmeter. Okay, so he's going to sit on the documentation. And we're going to fire this amp up again. Here we go. A little harder for me to read the grid voltage as I happen to have the amp open, and it's not open right now, so we're just hoping. Yeah, looks like lots of fun to a cat, doesn't it? Mm-hmm. And keep your eye on the fan. I got my eye on the voltmeter. Here we go. Beautiful. Well, this is showing an output imbalance voltage of nothing, of 0. Does that mean we got this guy fixed? Now with these amplifiers, as the tubes heat up, of course they change their 0 point. Let me put this meter a little more sensitive. Yikes. My 0 is way off. 0 here. Okay, we're just about 0. This is suspiciously zeroed. Adjust the DC balance setting. Alright, it's moving it. So is the cat. Come on, what are you doing? Don't go into there. Nothing there for you. Once again, the cat has been a great assistance. This amp appears to be operating, so let's drive a little sound through it. First, I'm going to connect it to the speaker. The easiest way to do this is with a couple clip leads. And because there's a propensity for the clip leads to touch, I clip them like that. They're not likely to touch them. Okay, here we go. So I would say there's still a small DC there. The speaker's right near my camera here, so you should hear it pretty good. Here's some funny sounds. Not very nice. Okay, things are getting hot, so I've got to put on my glove here. What's making that sound? So, bad pin contact on this tube is making that sound. Balance is still good. So now what we're going to do is we're going to feed a signal into it. signal's going to be from my radio here.
At least last year with plenty of male nudity. No.
Okay, so what I've got here is the output from a small radio. And right now the output is turned down to nothing. Boy, if I put this in, this could cause a huge hum as I push this in. So we're gonna... That could be an exciting hum. This amplifier is basically running wide open all the time. It's dependent on a controlled input signal. If I put in an uncontrolled input signal, like a small hum, it's going to come out of here like crazy. Wow, this is hot. I'm going to heat up my whole house with this thing. What do you got down there, Draper? He's found something interesting on the floor. Good for him. Balance is still pretty good. Well, I can't afford to plug this in and have a huge sound go through and blow up my little speaker in the whole shop. So I'm going to shut it off. It's off. You plug in the supply. The volume is turned minimal. So we're going to restart this. Let me get another cooling fan in here. Because it's unbelievably hot. It's ridiculously hot. It's roasting here. Wow. Okay. Another clip with it. What is this one? Okay, we're ready now for another test. The speaker is connected this time, but the input is set to 0. Here we go. Gotta wait the 45 seconds again. Wow, I can see an imbalance voltage on the output sitting there right now. Let's see what happens. So that voltage is going through my speaker. Here we go. Well, I hope it's working. Because as soon as the relay snapped, the voltage fell to 0. The cooling fan is still operating, so here we go.
He assumes, oh, my grandfather's Playboys were in the attic, and I looked at them as a young man. Women don't have that kind of validation where, you know, it's okay for us to subscribe to something like Playgirl, or if that's not your thing, it's still really not okay to come out and say, I'm interested in sex. I like looking at naked photos, whether they're of a man and a woman together or a man posing by a tractor, which is something that we would feature inexplicably in the magazine. But I just don't
we'll check the imbalance voltage with this meter.
That's okay.
Can I just say, before I let you go, Ronnie, you're right that you just said as well that though the Beefcakes and Playgirl appeal to your female audience, some in your audience, they weren't always your cup of tea. Do you think there is enough variety out there in terms of the images of the male body targeted to heterosexual women?
Absolutely not. I mean, I talk about this in the Atlantic piece as well, that when we see male nudity in the movies, something that might be appealing to women, it's always sort of joke nudity, like Seth Rogen or some kind of comedian doing it as a one-off joke. I want to see James Bond, Daniel Craig, with full frontal nudity, and I think a lot of women would agree with me that that would be incredibly sexy, but we'll never see that. We'll see Halle Berry nude. We'll never see Daniel Craig nude in a Bond movie.
We're reading 0.3 volts.
I don't think so. I hope so. We can hold out hope, Jan.
Thank you, Ronnie.
Sure.
Well, it's a pleasure to talk to you. Thanks very much for coming on the show today.
Thank you.
Bye-bye. Author and former Playgirl editor Ronnie Koenig. She's written a piece in The Atlantic titled What Being Editor-in-Chief of Playgirl Taught Me About Women and Desire. She joined me on the line from New York. I want to bring in journalist and author Daniel Bergner. So his latest book,
as close to zero as I can get, that's 4 100ths of a volt.
Looks at how latest research
it's 4,000ths of a volt, 4 millivolts. That's
ideas
tiny.
about women and sexuality. He's also joining me from New York in our studio there. Hello, Daniel.
And that's also why I couldn't see that on this meter.
On the show. You've been listening in on what Ronnie had to say, and you tackle this book in terms of scientific research in this topic.
Let's let it operate
what
for a
does
little
the
while.
current research say about women and visual desire vis-a-vis what Ronnie was just saying?
Right. Well, I've spent about 8 years now with scientists, most of them women, studying female desire and then interviewing everyday women so that I could thread their stories through my book. And to start with the questions Ronnie raises, the point she makes about women and visual stimuli, definitely I think
so here's the setup.
Underestimated the part that the visual plays for women, and I think that's quite convenient.
There's the imbalance voltage.
For men that we do so. After all, for me, it's easier not to have to worry so much about how I look.
It's changed a bit since I said
Research
it.
is certainly telling us that we should take a closer
Looks like it's drifting very, very slow.
The visual does play probably a very important.
There's the other one that shows the imbalance voltage.
Groundbreaking research to some extent, the points out these studies.
That's the line voltage. It's 110.
Just explore a little more what those assumptions.
It's 110 because of the voltage drop on the extension cord and my other equipment.
One overarching assumption or theory that we've long been fed, which is that evolution has programmed men to spread their cheap and more or less limitless seed, thus to be promiscuous, and women, by contrast, are programmed to seek out one good man, to be more or less well-suited to monogamy. I think science is giving us now a very different, I think ultimately empowering vision of women's sexuality, though again, one that may be a bit unsettling for men.
Why is it so unsettling for men?
Well, because it's nice for me to think that
Hey, let's measure the temperature on these things.
My thoughts might wander. My partners are largely focused on me, but research
Temperature
is
meter.
something very different.
We want the ability to do that and to have women not be able to.
Of course, that is so nice.
Okay.
And I'll just give you a couple of quick examples of the kind of research that I assemble in the book. So, to start with, a study of 2,500 committed couples. So no small number. Results probably not a fluke. And what you see is that desire
Very high temperature readings there, but
starts at about the same level for men and women. So this isn't an issue of
some noise
women
coming.
being somehow less libidinous. Male desire declines fairly gradually.
What's that?
Tends to plummet. So really turning upside down our assumptions. Another study by a fascinating researcher.
Sorry. Put the camera down. Well, the noise, I think, is more pin noise.
One among many great comparisons. Take a handsome stranger on the one hand, an equally handsome, trusted close friend on the other. Women say the close friend turns them on more. Their bodies say something else entirely. This isn't to say, I should be careful, that the body speaks entirely, completely desire, and that what women are saying is irrelevant. Not at all. But it is, again, a wake-up call about the way we've kind of kept a set of societal blinders on when it comes to women's desire.
With respect to the blinders and the discomfort for men, your book also mentions several times that women's sexuality is a feared thing. One of the researchers called her work taboo in scientific circles. When you discuss the search for a female Viagra, you write there is a concern in the industry that creating the sexually aggressive woman. Why?
Okay, I saw something pretty unusual there as I wiggled this tube. I saw that the power drain when this amp went up. I could see that because the line voltage meter dropped a bit, indicating more power being drawn by the amp. So that's a very strange result. Nothing else seemed to happen. That's really bizarre. So let's take a close look at the imbalance voltage again. Still very low. 2 100s.
I think it's two things. One, it's the sort of simple fragility of the male ego that we were alluding to earlier. But there's another larger issue, which is
going quiet.
And that is, it's so nice for society to think that half the population is somehow programmed to serve as a sort of social glue, as a force to keep our society together. Well, that puts a terrific burden on women, and again, I think distorts our understanding of who women are sexually, who we all are sexually.
Good topic, eh? Let's try this again. Now.
Notion of living long-term monogamous relationships.
I think it definitely puts that into question. You know, throughout the time of reporting the book, writing the book, I wrestled with this a lot. I'm in a monogamous relationship. I'm not about to toss out that monogamous relationship. Sometimes I look over at my partner and think, or even ask, you know, how many more months of your desire am I going to have left? I'm not sure that this all means we have to dispense with monogamy, but I certainly hope people put down my book, after reading the science, reading women's stories.
Definitely hear that sound again. Very scared to do this, by the way. Momentary break of a connection. A very loud pop will come out of that speaker, making me jump. Whoa, not interesting. Look at this. All I'm going to do, you can see that meter, by just putting my hand in proximity to these tubes. See it move? This is the noisy guy. So we'll do something about that tube right there. Why is that one noisy? Ooh. Uh-oh, I got imbalance voltage going way off. That's my fingers again. Some sensitivities here that. Let's check the imbalance again. It's still around 3 hundredths. Around 3 hundredths of a volt. Okay.
About that effort to get beyond nurture to nature, to get beyond the learned to who we are at some fundamental core. That's on the one hand quixotic.
Okay, I think we're going to shut her off now. Pretty big voltage sitting there. Well, it's not big. know, these are huge capacitors. They could be delivering some charge through the circuits. It's so small. Let's just compare using this meter here. This meter shows 0. Something not so smart about my other meter. Better not rely on that older vacuum tube meter for these precision measurements of tiny voltages. I'll continue to rely on this guy for it. So what I'm going to do is pull this tube out and take a look at the pins on it. It's not that common to find corroded tube pins or problems like that, especially with an amp like this. I mean, this has not been sitting in somebody's garage or something. This has been well cared for. Well, the pins appear to be just fine condition. And these are pretty good sockets, it looks like. So why it was doing what it was doing, I don't know. Okay, so I'm going to let this cool down. Then we're going to switch our attention to the sister amp. This is a mono block. I have its brother. Maybe sister. And we're going to change the big capacitors on it and change out 2 resistors that are in it. So, and we'll also we'll put it on